let's do an example, and in this case we have a plate over here that has a positive charge, and another plate which is parallel to it which has a negative charge. The length of these plates is 0.1 meter, and there's some gap between them which is not so relevant right now. And we have an electric field in here which goes from the positive towards the negative, and we will take a certain value of that electric field. This is E. So the electric field, we just take it as 100 newtons per coulomb, and we have a electron moving this way with a speed of 4 into 10 to the power 6 meters per second. So electron comes into this electric field. So what happens to it? Well, this is positive, this is negative, field is this way, so the electron, being negative, will be attracted toward the positive plate. So instead of going straight out, it will be pulled upwards, and its path, as soon as it enters this region, will be experiencing a force, and it's going to keep turning upwards, and then after that point it's going to keep going straight. So we want to find the force on the electron. Now the force is given by K, or let's use E times Q, and the electric field is here, which is 100 newtons per coulomb, and the charge, because it's an electron, is going to be minus 1.6 into 10 to the power minus 19 coulomb. The coulombs will cancel, and this will give us an electric force of 1.6 into 10 to the power minus 17 newtons. Now, what is the direction of that force? So if we take this as the x direction and this as the y direction, so this is I and this is j, the electric field is pointing in the negative j direction. So we have a negative j direction for the direction of the electric field. The two negatives will make this positive j. So the force is in the upwards direction. Now we use the equation F equals ma to find what's the acceleration, and that's going to be in the direction of the force, so it's going to be in the j direction. It's going to be F over m, and that's 1.6 into 10 to the power minus 17 j over the mass, and the mass of the electron is 9.11 into 10 to the power minus 31 kilograms. 1.76 rounded 3 figures into 10 to the power 13 meters per second square. So it has a tremendous acceleration upwards. And now if you want to find, well, if it was going straight, how far is this distance from where along the line on which it entered and where it's leaving? So we can use yf equals yi plus vit plus half at squared, and all of these will be in the y direction, and the t, okay, what is t? So we use the x equation, xf equals xi plus vit plus half a, this will be axt squared, this will be ayt squared, and this will be v initial in the x direction, v initial in the y direction. Now there's no acceleration in the x direction, so this term is 0. X final is here and x initial is here, so x final is 0.1 meter, x initial is 0, v initial is 4 into 10 to the power 6 t, which gives us t as 0.1 over 4 into 10 to the power 6, and therefore t equals over 46 2.5 into 10 to the power minus 8 seconds. And now you can plug this t in here and see y final is going to be y initial. If you take this as the y initial is 0, v initial y is 0 because it is purely in the x direction, plus half acceleration is here, 1.76 into 10 to the power 13, and the t is 2.5 into 10 to the power minus 8 whole square. Comes to 5.5 into 10 to the power minus 3 meter, or 5.5 millimeters.